Hey everybody, welcome to ARE Live. I'm Mark Tier, the founder of Black Spectacles, and today we're going to talk about the ARE 5.0 case studies. After this episode, you're going to have a good game plan for how to complete the case study, regardless of which exam you're taking. And Mike has some really helpful tips that are going to help you navigate all the information that you're given, because you're usually given a lot for these case studies. So you're going to walk away with a bunch of stuff. Before we get started, if you'd like to attend our next ARE live broadcast, where Mike is going to do his now famous top 10 tips to pass the new exam, ARE 5.0, you can visit blackspectacles.com/podcast to register. And in fact, if you're sitting in front of a computer right now, just type in blackspectacles.com/podcast. And there's a link right at the top. You can register right now so you don't miss it. And if you do miss it, as long as you're registered, we'll send you a recording anyways, so you can register just to be sure. And like all of these ARE lives, during the broadcast, you'll have a chance to ask questions to Mike and share with the group. As you guys probably know, here at Black Spectacles, we have video lectures, practice exams, and flashcards all on the web for ARE 4 and ARE 5.0. And we've spoken about this a couple of times. We also have our new group coaching program. And actually, we're speaking to you today on May 8th. Applications are now open for our July cohort. So if you're interested in participating in one of our group coaching, in our group coaching program, you can go to blackspectacles.com/group coaching. What's nice about it is that sort of the goal of the coaching program is it gives you some structure and support to get through the exams. We bring a recently licensed architect who will be your coach. And then we really do, I think, a really kind of thorough job of handpicking the coaching candidates because we're looking for people who are really dedicated to finishing the exams and taking them seriously. In fact, what you end up doing is you and your group commit to taking all of the ARE 5 exams on a schedule of basically one exam every month or one exam every other month. So it's a pretty serious group. And we do have limited spots available, so you can apply now. Again, if you go to blackspectacles.com/group coaching, applications close on May 18th. So we're 10 days away from that closing up. Another announcement, which we're super excited about, if you haven't already heard, Black Spectacles is the first ever NCARB approved test prep provider, which is, is pretty awesome. We've been really excited about it over here. Last month, NCARB approved all of our ARE 5.0 PPD and PDD study materials. Those are the two big exams.
And if you're in the transition?
Yeah, exactly. If you're in if you're in the 5 exam plan transition where you're taking some in 4, the last 2 that you take that are a part of ARE 5.0, PD and PDD, those are the 2 exams that were approved. And that included, they reviewed our lectures, our practice exams, our flashcards, the whole bit. So we've submitted the other ones for review just the last week or so. So we're really excited about getting everything approved for you guys. Lastly, I often like to remind folks, if you'd like your boss to pay for your Black Spectacles membership, be sure to tell them about our firm licenses for any size firm. It doesn't matter if you work at a 10-person or a 10,000-person firm. We have a license that gives multiple folks access. You have a group admin, reporting, and all that good stuff. Again, blackspectacles.com/firms to learn more about that. And then, as always, we have a special discount for individual memberships, which we'll share at the end. In addition to all of that, at the end of today's episode, we'll choose someone from all the folks who submitted their answers to the mock case study, and they'll win a free 1-month ARE Prep Black Spectacles subscription. And we'll be tracking all your answers. Everybody who gets them all right will get a free Black Spectacles t-shirt. Man, that's a lot of stuff. My guest today, I'm sitting next to Mike. If you don't know Mike Newman is a senior lecturer at the School of the Art Institute of Chicago. He's also the founder of Shed Studio, and he is the instructor for Black Spectacles' online ARE exam prep video curriculum. If you haven't already checked out that curriculum, you can go to blackspectacles.com to watch any of the free videos from the courses. Today we'll be taking questions using the GoToWebinar question box, as well as on Twitter using the ARE Live podcast hashtag. And with that, I'm going to hand it over to Mike.
Okay, so before we dive into the questions, I just want to give a little bit of a background sense here about the case studies. Most of you probably understand the case study, so I don't want to spend too much time, but Under 4.0 and 3.1 and 3.0 before that, there was just straightforward one-off multiple choice questions. And then there was also the vignettes, the drawings that you had to go through to draw a section or to do a mechanical plan on a reflected ceiling plan, that kind of thing. And in the effort for NCARB to make the leap and make it more like being an actual architect, they decided finally to get rid of the vignettes. And so all that drawing stuff is gone under 5.0, which is great. That's a good thing because the vignettes were always a little goofy. And the case study is the big effort to sort of make the leap away from just like one and done kind of questions and to make it feel more like what it's like to be an architect. And this is a smart thing and it's a good thing, but it also creates a little bit of a sort of different scenario than most of us are really used to on an exam situation. So the way this is going to work is there's going to be a bunch of questions. Let's say you have 100 questions on an exam. And the first 70 of those questions are going to be just like the old time ones. There'll just be one question, you answer it, and one question, you answer it. And they're all individual. But then you might have, by the time you get to 70, maybe you have 2 case studies at the end. Could be 1, could be 2, but let's say you have 2 case studies at the end. And when you get to that point, when you get to that case study, there'll be a screen that has a series of tabs along the top with lots of different pieces of information. It might be 3 or 4 pieces of information, might be up to 6 or 7 pieces of information. And those pieces of information could be drawings, it could be code bits, it could be a change order, any number of different pieces of information that might be useful in answering the next, say, 15 questions. It could be anywhere from about 10 or 12 up to 20, 22. But I'm guessing that they're probably going to average around 15 or so. And so you're going to get roughly 15 questions that pertain to a particular project, and that particular project is shown through these different tabs. So all of those tabs are going to relate to the same basic project. And then the series of 15 questions are all about that. So the idea, and then if you have 2 case studies, then you'd finish those and you'd do the same thing again. And you'd have another set of tabs with a whole new bunch of information and then a bunch, 15 more questions. And then that would all total up to 100. So that basic idea of there being a bunch of information, a bunch of different tabs that you can move through this information and then answer these questions, the big deal here is that you're going to have to get used to the idea that you're not reading all of the material. You're going to read some of it, and you're going to know that you need to be able to access the rest of it. So it's supposed to be more like being an architect. So let's say you got some of a code, a zoning code or building code. You're not going to, before you start answering the questions, read 50 pages of a zoning code or 50 pages of a building code. You are likely to get a couple of questions that then you would have to go find that code, tab through it, find the correct piece of information, and then report that back in one of the answers to one of the questions. Much like you would do as an architect. As an architect, you get a problem and you got to figure out, there's part of the thing that's going to answer that problem is what does the client want? Another part that's going to answer that problem is going to be what does the zoning code allow? Another part might be something else. And so you have to go through and find that information in the tabs that you've been given. So this should be familiar to all of us because we're all doing this kind of work all the time. But it is a little awkward. It is a little funny. You have to get sort of good at kind of going through the material and knowing where to look and thinking ahead and all of that. Now, as we do it in this case, for those that got it the information sent out to you, you've sort of already had this issue. We don't have the whole setup here, so it's tabbed a little differently. We're going to be scrolling through things. And given the fact that we're going to be scrolling through things, there'll be a few moments where I'm just going to kind of cut to the chase, but we'll talk about how you would have to figure out where that moment is. But just in the interest of time, I'll kind of jump to certain elements. So given that, what we've got here is a sort of simple version of a case study. And so we've got a bunch of supporting information, the tabs that you'd find on the exam, and then a group of, in this case, 11 questions. So let's jump in. Okay, so here's our first question. And we're going to look at the first question, and then I'm going to jump to the tab information, and we'll go through that for a second, and then we'll come back and actually start really trying to answer this question. So the first question is, how many drinking fountains are required in the building design? Assume that the building is 40,000 square feet gross area. Well, right away you realize, wait, I don't even know what we're talking about here. I need to go look at the information that they've sent so that we can figure out what to do next. So let's take a look at that. We'll run through some of the information. Now it's going to be a little awkward, so just bear with me as I jump back and forth on the screens, and apologies on my end of not being so great at making that smooth and easy. But here's the table of contents. So this is effectively our tabs, if you imagine the tabs across the top of a computer screen. So we've got the scenario, we've got a program, in this case, we have a phase 1 environmental report, we've got a climate analysis, we've got the zoning code, we have a zoning map, we have an aerial photo, and then we have excerpts from the IBC, the building code, the International Building Code. So probably the first thing to do is take a look and read the scenario. So we're going to take a quick look at that, and I'm just going to read it out real quick. Scenario: you are the architect for a new office building for a small to mid-sized business. It is a new technology company called Jumpster. That business has needs that will be obvious, things like administration, financial departments, marketing, stuff like that, and some less obvious, prototyping, like the client has some specific ideas about how the workplace should operate, what it should feel like, and how people should be communicating with each other. Essentially what the experience should be like to work there. But there are certain realities that we must deal with as well, such as land use, zoning issues, contaminants, a whole series of those other things, and that's essentially what's represented in a number of these different tabs. Then there are a few questions that cover issues. There are a few questions that cover issues covered by all of the supporting documents. Some issues may be answerable by just reviewing one document. Others may have to be interpolated between multiple pieces of information from multiple sources. So that's the general scenario. Then we can take a look at the program. So the program means that it's the information that's come from the client as part of the signing of the contract. Now, these are sort of simple versions of things, so this is actually a relatively simple program, but you'll see that it has that general information and it's got some goals, and then as we go down, it's got, I zoomed by it. Hang on a second here. Yeah, let me try doing it this way. No, that's taking me on the tabs. It's got some information about the number of employees. It's got some information about how much square footage is expected for each of the different departments. And then it's got some conclusions, sort of general problem statement for the project. And then after we take a look at that program, we can see we have an environmental phase 1. And so the phase 1 is just that preliminary. It's a few pages long. It's probably not going to do a big long discussion about the difference between phase 1 and phase 2 right now, but the idea is that phase 1 is where you go in and say, there's a site, we're not really sure if there's any issues. We get some professionals, environmental engineers and environmental scientists. They take a look through the information about the site, they look at the site, maybe through photos, maybe in person, but often not. And just look at the history of the site and come up with whether there's likely to be any problems here. So this is an environmental phase 1. If things are problematic, then you would probably get an environmental phase 2 where all the actual testing happens. So we've got the environmental phase 1 about the site. And this is essentially the executive summary of the phase 1. An actual phase 1 would be about 100 pages long, but the executive summary is just a couple pages. So there's the phase 1. Now we have a climate analysis and environmental proposals. And so this is just giving you a sense, we've got some information here about the climate. It's a temperate climate. It's at 40 degrees latitude. It talks about being a relatively cold winter, reasonably warm but not super hot average summer, a little bit of information about the site, and then a series of proposals down at the end of that page that are regarding climate analysis and environmental aspects to the project. So you can see under the proposals, daylight capture, maybe geothermal, controlled cross ventilation opportunities, whole series of different things along those lines. Then we have a portion of the zoning code, and this is multiple pages. And so it's going to have FAR information, setback information, parking information, a whole series of different aspects of that. So that's multiple pages. And then there's going to be the zoning map. And on the zoning map, you can see we have the site called out. It's a B3-3. And importantly, you notice a couple of other things. There's an element here called a pedestrian street. Different municipalities will have different ways that they talk about these things, but there's specialized streets where the municipality wants to emphasize and make sure that they don't accidentally make really dead streets. This wants to be a relatively lively street with lots of windows facing to the main street. So that's a pedestrian street. And you also note that very close by there's a transit station. And then there's a aerial photo just to give you a sense of it. There's the site. You can see the transit station. There's an open site just to the southeast. So there's some opportunities here. You can tell there's residential nearby, et cetera, et cetera. And then the final piece of information we have is the excerpt from the building code. Now we haven't put the whole thing in, but it's actually a lot of pages even with just this. So you can see we have the use and occupancy classification, we have the general building heights and areas, we have types of construction, we have Chapter 10, the means of egress, and then Chapter 29, plumbing systems. So there's a lot of information in that IBC section. We have a general idea of what's going on. We've looked at the site, so we have a sense of kind of what generally is happening. We understand by looking at the zoning map that it's a B3-3, that there's residential nearby, that it's on a pedestrian street, which is a special classification, and it's near a transit. We can look at the zoning code and start understanding. We have the floor area ratio, the FAR here. You can see we also, at the bottom of that sheet, we have the front setbacks and then the rear setbacks. We've got some building height information. We have the parking table that tells us how many parking spaces we're going to need. So we've got a series of pieces of information there that are going to be useful. The climate analysis and the program. Let's look back at the program for a moment just before we jump back into the questions. So taking a quick look, we can see that we've got some general goals. We want a high-performance building. We want efficient groupings for the office and the departments. We want natural light for all, down there, number 12. Everyone is near the exterior, number 13. So there's a bunch of information in there, and if we had a minute, we would probably read through that whole thing. I'm going to kind of skip along for now. And then on page 2 of the program, it talks about how the site is 20,000 square feet. We have 170 feet of street frontage along the main pedestrian street that we were just looking at on that zoning map. And then we have all of those folks. We have the number of people listed out per department, and it comes out to about 220. Now that might change, but it's going to be approximately that. But then we're adding in 20% for growth, so that's another, I'm sorry, that should be 200, I believe. I think that was a typo there. So then that comes out with the growth added into 240 employees. And then the number of square foot per department, we'll see if that becomes useful or not. Okay, so we're going to jump back to the actual questions. And we're going to take a look and remind ourselves what the first question is. How many drinking fountains are required in the building design? So we're assuming that the building is 40,000 square feet. We're assuming that from the program, if we looked through, there'd be some information that says this is what we're aiming towards. So then we have possible answers: 1 drinking fountain, 4 drinking fountains. There are no requirements for drinking fountains in business occupancies. 2.5 rounded up to 3 drinking fountains. Well, one thing I can definitely tell you is it's not C, because drinking fountains almost always are in fact required in business occupancies. It's a thing that's important to folks it's just one of those things that shows up all the time in pretty much every code. So we got to figure out how many drinking fountains are needed. So first thing we're going to do is we're going to take a look at the IBC, and we note that the plumbing chapter is way down at the end. And so I'm going to zoom as fast as I can to the end. It's going to take a second, so give me just a minute.
We need some music
Is there
for you.
a way I can get rid of that thing so I can get to that?
No.
Okay, here it is. Okay.
We need some scrolling music.
Yeah, we do need scrolling music. That would be nice. So you can see we're going through all of that egress stuff and all the way along here. Okay. We get pretty close here to the main plumbing information. Okay, here we are in the plumbing section. We take a look down here. We've got a table, minimum number of required plumbing fixtures. You can see they have for different classifications. So they have the classifications called out over here. And then water closets, lavatories, showers, and drinking fountains. So that's the one that we're really looking for. So let's see if we can find, we can do it this way. We're in the A's, those are assemblies. We're still in the assemblies. There's business. So we've got business right here. Here's the drinking fountain line, and it says 1 per 100 people. So then an interesting question is, well, how many people do we have? And the answer we just looked at in the program is we have, even if we include the growth, 240 people. But is that the actual right number? And the problem here is, it's one thing for our client to want to have 240 people there, but that isn't necessarily what we would use for the calculation on this, because we actually need to have it be something that matches, like let's say this company goes out of business next week and a different company moves into the building and they have a different number of people. The number of drinking fountains, the number of bathrooms, the number of water closets, all that stuff has to work for whoever moves into the building. So the scale of the building and the occupancy, those two pieces of information are the thing that we would actually really need to think about. So we have to know in a business, so this is, the occupancy is business, in a business environment, how many people does the code think are in this building. Not how many people does our client imagine putting into them, but how many people does the code think? And that's going to be a per square foot way of understanding it. And so that's actually going to be in a totally different section. We're going to be in the section that is about egress, because that's where they're going to define that, where they're going to define the occupancy count. So now I'm going to go zooming way back up all the way through that code. And when we're in that section, here we are, table, in this case, 1004.1.2 is the maximum floor area allowances per occupant. So the first bunch of those are all regarding like aircrafts and a bunch of other stuff. So we need to go to the next page. We're looking through the next page and we see business, and it says 100 gross. So 100 square feet of gross area per person. Well, we talked about how the building was 40,000 square feet. We divide that by 100, means we have 400, not the 240 that we were thinking, but 400 people occupying this building according to the code. Now, there are actually a bunch of ways you can start to alter that number. There's some exceptions here and other things there, but for the most part, you're going to find that that's going to be a pretty straightforward thing. So our actual number is going to be 400 people, and it was 1 per 100, so therefore B is our correct answer.
And there's a couple questions here.
Yeah.
Folks are asking about the search tool. So there is a search tool, and actually if you use, so we built, at Black Spectacles, we built our practice exams with the exact same tools that NCARB has on their real exam, and it looks the same and everything else. So it's like we tried to sort of replicate it as closely as we could. And so if you use our practice exams, you'll get a sense of how it works. And a sense of how to use the search tool. But there is a search tool that allows you to search.
So there's pretty good tabbing and a search tool and a bunch of other, it's just in this context, we have to kind of scroll through everything. So apologies about that.
So thanks Carla and Philip for those questions.
Okay, let's go to number 2. Which of the following structures spans are most likely? So we have concrete joist pan construction with 18-foot spans, structural steel wide flange framing plan with 35-foot spans, open web steel joists spanning 65 feet to masonry bearing walls, 2x12s at 16 inches on center with 24-foot spans. So this is kind of an odd question. This is really just trying to get, if you look through the program, you'll see the sort of dimensionally, and you look at the plans, you'll see dimensionally a bunch of opportunities to sort of answer this from a number of different angles. But I actually think the easiest way to answer this is there's nothing in any of the program information that would ask for anything unusual, and pretty much for this kind of context, all of these are unusual except B. That steel wide flange with roughly 35-foot spans is for an office building going to be the kind of typical situation. It means that our windows won't be very far away from all the people, so we'll have windows in the courtyard side and the other side. So it just sort of answers all of the issues. The 18-foot spans are just too small for this kind of use. The 2x12s just don't make any sense for a 4-story building that's new construction. From a fire rating standpoint, and the 65-foot spans, open web steel joists. We might do something like that if there was some very pronounced reason that was put into the program that said we really want to have long spans, but that's going to be much more expensive and difficult. It's going to bounce a lot. It's going to be difficult to make work in this kind of context. So really the only sort of logical answer is steel 35-foot spans. So that's a little bit of an odd one. You can find it in a couple different ways through the tab information or just answering it from the way that we just did just now. Number 3, what hourly fire rating will be required for non-bearing partitions in the interior portion of the building? excluding any demising walls. So not the corridor walls, not walls between any units or anything like that, but just general, regular interior partitions. So this one, we would again go back to the IBC. So we're gonna go back into the IBC here. And we're gonna look for our a rating table. So I'll tell you what, I'm gonna jump to here. And we're going to find it under the types of construction section. So we're going to zoom ahead, and we're going to find this appropriate table. Okay, let me zoom in here. I'm going to cheat a little bit. All right, so here we are under types of construction, fire resistance rating requirements for building elements, and we have primary structural elements, bearing walls, exterior and interior, and then here we have one for non-bearing walls and partitions exterior, but that's not what we want the interior, which is the next one. So this is the one we're looking for, and now we have to understand, well, which type of construction is it? Type 1? Is it type 2? Is it type 3? We would have to know in order to be able, because each of these numbers is going to be different, and so we'd have to figure out what type of construction. But as it turns out, if we take a look through, it's all 0. So we can actually answer this one by just saying 0. There is no hourly requirement. Okay, number 4.
We are knocking people out of the drawing here. We were down to 13 previously, and the pickings are getting slim. I think we're down to 11.
Yeah,
10.
We're gonna. We'll be okay. We'll catch. We'll get. Somebody will win this thing.
Good.
Number 4. In a fire emergency panic, how many rated stairwells are there required to be found in the floor plan to get people to safety? So this is a big enough building. You know, if we have, it's 40,000 square feet, 10,000 square feet per floor. You know, if you have a reasonably sized building and you've got fully sprinklered, you can sometimes get away with a single stair exit, especially for one floor above grade, that kind of thing. This is a 4-story building, 10,000 square feet per floor. You're going to need 2 stairs. There's really no question. The only question is whether we need actually a 3rd stair. You know, it's not so big that we're going to need a 4th stair. So I can pretty much guarantee you, just from knowing what I generally about how these things go, that it's probably answer B and might possibly be answer C. So if I was in a hurry, if I was running out of time, I'm just answering B because 2 stairs, totally standard. There's only reason it would go more than that is if it was either a lot of people, so therefore like an assembly space or something like that, or a really big square footage footprint, which then when we divided by the 100 square foot per person that we just found a few minutes ago would be, again, a big number of people, or there's just really long distances. But none of those seem likely. It all seems pretty compact, so it's probably B. But let's just sort of convince ourselves. We already went through the exercise of understanding that we have about 400 people in this building via the code occupancy. So let's take a quick look back into our important little element here, the IBC. And if we had a little more time, I'd scroll through it and you'd kind of see all the different headings. But when we come down to 1006.3.1, see minimum number of exits or access to exits per story. So this is talking about not just horizontal exits, but actually when you're going up and down in the stairwells. And it talks about the occupant load. We have 1 to 500 has 2, 501 up to 1,000 has 3, and then 1,000 or more has 4. Well, we're less than 500. We're at 400, so we're doing just fine with that 2-exit scenario. So the answer here, B, 2 stair exits are required.
Now, Mike, one thing that folks might be thinking is, and I know every time I stare at a code, the amount of sections and things that are in like a code can be really overwhelming.
Yeah.
But can you speak to the idea that once you've practiced this and once you've done this in real practice, like you kind of get used to like, oh, I know to go look for this. I kind of know, and so even though there's like 4,000 sections or whatever it is, there's actually like a bunch of key ones that you kind of get an intuition about where to go.
In fact, one of the things that happens, even though the code is a gazillion pages long, I'm not sure that's technically correct, but it's a gazillion pages long, you'll find that you keep going to the same pages.
Yeah, right.
So the occupancy count, the description of construction, the different relationships of, like if you're doing residential buildings, you go and you look at the occupancy about residential because there's a bunch of key pieces of information there. So out of all those 1,000 pages, you'll spend 90% of your time on 30 of them, something like that. And you actually start to get to know those pages pretty well. The trickiest part is, and I will admit I'm kind of glossing it over a little bit in this context, we have an example coming up, but is that often you have a very straightforward answer and your immediate inclination is to just, oh, that's the answer. But you do actually have to keep looking at the next bunch of information, the exceptions to that rule. Often you'll find it'll say, you need 2 stairs in this situation. But it turns out if you're sprinklered and only 2 stories, you can get away with 1 stair if the distances are less. And suddenly you can get away with 1 whole less stair, which is a big cost saving. Now, there may be other reasons as architects we want to always have 2 stairs, but you have to be a little careful. The information is actually relatively easy to find, but then you have to make sure there's not sort of hidden little extras that you want to get through. But yeah, once you've done this a few times, once you start moving through it a few times, you'll find that it actually is you're much more knowledgeable about what's in it than it may seem. And then there's going to be a bunch of sections that you never look at that, maybe somebody else doing a very particular kind of project. There's whole pages and pages and pages on airports. Maybe 2 people who are listening here are going to work, on an airport at some point. But so most of this stuff is going to be
shout out to the airport architects.
Yeah, way to go, airport architects. Most of the stuff is going to be stuff you can just sort of zoom right by, and like I say, you'll get used to it. Remember that whenever you're doing a code search, you're always starting with occupancy, and then jumping to construction type, and then jumping to like height and area limitations. How big a floor plate can it be? How tall can it be? That kind of thing. And if you can't make it work, then you've got to go back and revisit the construction type. So you're always starting with those 3 things, one right after another, and going back and forth to make these numbers work. And then you're going to be going a little deeper into the plumbing and a little deeper into the size of the stairs if it's not a public stair, and those kind of secondary and tertiary levels of information.
Cool. You made me feel better, Mike. I hate going through the code.
Yeah, you get good at it. But okay, 5. Which of the following are likely to be part of the project? Choose 3. So what do we have here? We have shallow floor plates to allow most spaces to have close access to operable windows. That sounds like something we read just a few minutes ago in the climate analysis. Vinyl window systems, since they have the best R values. Sun shading devices to allow maximum daylight. We also saw something in that about daylight. Let's take a quick look at that piece of information just so we can remind ourselves. So this was the climate analysis. Let's sort of run through this here. We have the proposals down at the bottom. And we've got proposals are to capture as much natural daylight, to block solar gain in summer, accept solar gain in the winter, geothermal with a question marks, which presumably means maybe geothermal, operable windows or venting controlled locally. Locally meaning like if there's a window next to my desk, I should be able to open it. Shouldn't have to call facilities department to come and open a window, and that there are in fact operable windows. Controlled cross ventilation opportunities. If you look elsewhere, there's a discussion about the idea of courtyard spaces so that you could start getting convective currents and controlled spaces. Green roof opportunities, maybe that could be shared as employee break areas. Stormwater runoff handled in a number of different ways: green roofs, porous pavers, underground storage detention systems, and French drain/bioswales. Night sky lighting, which just means any of your exterior lighting shouldn't be going up into space. It should be focused down to the ground. It doesn't really make sense for us to use globe lights outdoors because you're just losing half the light up to space. It's wasteful. And then extra bike racks and shower rooms. So that's probably where most of the answers are going to come for this. So let's jump back in. And we talked about how shallow floor plates to allow most spaces to have access to operable windows. Yep, we just talked about window and close by daylight and all of that, so that makes sense. Vinyl window systems, since they have the best R values, that is true, but if it's a truly environmental project, most folks will tell you, even though the R values are better on a vinyl window, the making of vinyl is so toxic that if you're doing a true environmental building, which has been asked for in the program and on the climate analysis, that's probably not the material you're going to want to use. But let's sort of think about that one. Maybe if we come back, it might still be a good one to answer. How about C, sun shading devices to allow maximum daylight and solar gain in the winter, but control the amount of solar gain in the summer. That's almost directly out of that one, so that's definitely it. So we only need one more. No elevators to encourage active, healthy use of the stairs. Well, that sounds great and would be a great, healthy thing to do. But really, you're going to have people working on the fourth floor and no elevator. And what about accessibility and et cetera, et cetera? So that's just not believable. You might put the elevator back behind the stair so that people see the stair first and then go up and down the stairs and try to get them to be more healthy that way, but you wouldn't get rid of the elevator in this context. Heavy timber construction, there's really nothing that says that heavy timber construction is part of what we're talking about here. And then F, green roof for stormwater control and garden amenity for office use. Again, it's almost directly out of that climate discussion, so those are your three. The only questionable one was really this B one, which it could have potentially been, but the other three are better answers.
All right, we're down to six folks who've got them all right.
Excellent. So I actually had gonna embarrass myself by saying I made a little bit of a mistake. This is the question that I had actually planned to take out because it's a little complicated in its actual answer, and I decided after I'd written it that it's too many complications. So is there a way for us to not count this one?
Yeah.
All right. So the question here is, where will a vapor barrier be located? And our choices are just below the siding material, on the cold side of the insulation, just inside the interior finish material. There is no vapor barrier in commercial buildings. Well, there actually is a vapor barrier in commercial buildings, although not always, not 100% of the time, because it can be a little complicated, but typically there is. And then the question is, where should it be? The typical answer in a temperate zone, which this is a temperate zone, would be C, just inside the interior finish material. And the reason we call it the interior finish material and not a more specific thing is there can be a lot of different, it could be Durock in some locations, it could be drywall in other locations, it's a bunch of different elements. And the reason for that is in a temperate zone, when it gets cold enough and you have moisture by people breathing, people making coffee, all of those kinds of things. You have moisture building up on the inside. You'll find that it will create a force difference between the dryness outside and the general level of moisture in the air on the inside, and that moisture will force its way right through the wall. The reason I was going to take this one out, though, is that with commercial structures, it starts getting very complicated. And in temperate locations, most temperate places, this would be the case. But if you're in the kind of southernmost element, but still in temperate, you might see it a little differently. So that was why I sort of changed my mind on this question. So I'm going to answer C, but like I said, it's a little more complicated than that.
Okay, good. Like that.
Yeah, sorry about that one. And for all of you who sweat over that one, sorry about that. I didn't mean to give you trouble. Number 7.
You know what? Actually, that's an interesting thought. In a way, that's almost like one of these test questions. You know, sometimes as you're taking the exam, you're like really thrown off by a question. You're like, what the hell does this mean?
Yeah.
Like, it could be this, it could be that. It could also be that the question doesn't count. And it's actually one of these questions that NCARB is testing to find out if it's a good question.
Yeah, because one of the ways that they get all of these questions is, out of the 100 questions that you might get on an exam, maybe 95 of them are going to count, but maybe 5 of them are like, well, let's try these 5 and see what happens. And then you're the guinea pig on those 5. And then, 6 months later, those might be real questions for somebody else. And it could be more than that. It could be, like I remember when sustainability issues really first started kicking up 15 years ago or so, everywhere we were talking to, people would go off and take the exam and they'd come back and they'd say, oh my God, you wouldn't believe how many sustainability issue questions we had. And that was just because NCARB was trying desperately to catch back up. And so they would have a few that were real and counting, but then they were testing a whole bunch more, and so they had maybe 10, 15 test questions on anybody's exam. At this point, it's not likely to be that. You're going to get a few here and there, and some are just going to be poorly written, and like that one is a good example of a poorly written, he says a little shamedly, that's an example of a poorly written question, and don't worry about it. Answer the question, move on, because who knows. All right, moving on. Number 7, which of the following are most likely to be included on the site plan, the landscaping plan, and the civil drawings? So something that's going to show up on all 3 of those. So we have encapsulation of the oil tank. We have a parking lot for 90 cars. We have a line of deciduous trees for wind control, and D, stormwater runoff systems. Well, okay, which of these can we get rid of right away? The answer to that is, without even blinking, we can get rid of C. Why is that? Because you wouldn't use deciduous trees for wind control. You would use coniferous trees for wind control. Deciduous trees are going to lose their leaves in the winter, which is when you're most likely to need wind control. And so they're going to be kind of useless for wind control. So C, not the answer. And I always throw something like that on there because that coniferous deciduous thing is just such an easy thing to ask a question about. It shows up in various odd places. So just know that pine trees, coniferous trees, keep their needles, keep their leaves all year, and therefore are great for wind control. Deciduous trees which get their leaves during the spring and keep them all through the summer and then lose them in the fall, are no good for wind control, but are great for shading because when do you want the shade? Well, in the middle of summer, and that's when they have the leaves. So useful for shading are the deciduous trees, useful for wind control are the coniferous trees. So we're down to 3 of them. Encapsulation details of the oil tank, parking lot for 90 cars, stormwater runoff. Now, if we went to our information to our tabs and went through the environmental phase 1, we'd find that there is, in fact, information about an oil tank. So there's something there that's going to be about an oil tank in that. But that doesn't necessarily mean that that's the information that's going to show up on the site plan, the landscape plan, and the civil drawings. How about a parking lot for 90 cars? Well, if we have a parking lot for 90 cars, that would absolutely show up on all three of those plans. You definitely would have, the civil plans would be all about where the curbs are and how the flow of water is. The landscaping plan would include things that give shade to the parking and block view of the parking. And the site plan, obviously you need to have the site plan to show how the parking worked. But 90 cars sure seems like a lot of cars. So something seems problematic to me there. If you did a quick example and you said, all right, if we have 300 square feet per car, which is a low number actually, usually it's a little higher than that, you multiply 300 by 90, you're going to get a really big number that's going to be significantly larger than the size of the site. And nothing anywhere talked about multiple parking decks or anything like that. So even though that is a plausible answer, the 90 just doesn't sound reasonable. So my guess is that the real answer here is going to be the stormwater runoff. Once we start looking at it, stormwater runoff issues absolutely are going to show up on the site plan, landscaping plan, and civil drawings because all three have to be coordinated. There'll be elements that show up that are part of the architectural end, green roofs, things like that. There'll be elements that show up that are about the plantings and how water is going to move through and the topography. That's going to be both on landscaping and the civil, and then obviously if there's underground elements, that would definitely be in the civil setup. And we talked about in the previous documents we were looking at that there would likely be green roofs, underground retention systems, detention systems, and bioswales and all of that. So all three of those are definitely going to show stormwater runoff systems. So my guess is answer D. But let's just take a quick check on the 90 cars. That's my hunch, but let's take a quick check. So I'm going to go to the zoning code. We're going to take a look through. We've got FAR. We've got some floor area ratio stuff and some setbacks, maximum building height. Now we've got parking and off-street parking requirements. So the first two down at the bottom there are residential. Then we get to commercial and to business. So here we are in business 1, 2, and 3. This one is talking about business with pedestrian street focus. Remember, we have that whole pedestrian street thing. So this is our likely candidate here. And it says no spaces are required for the first 10,000 square feet, and then one space for every 1,000 square feet after that. So we have a 40,000 square foot assumed building. We subtract 10,000, leaves us 30,000 square feet. We divide that by 1,000. So we've got a parking lot of 30 spaces. Now, things might change a little bit. We might go a little bit larger in our building. We might go a little bit smaller in our building. But that means we're going to go from 30 to 31 or 30 to 28 or something like that. We're not going to jump to 90 unless it's said in the program, well, the client really wants to have a lot of parking. And it doesn't say that. So we can assume when we go back that 90 cars is just not believable, and therefore the best answer here is D.
Okay, down to 4, folks.
8, which of the following will likely be included in the fenestration system? Choose 3 that apply. Okay, we have low E coating on surface 1 on the south side. We have B, reflective sills and horizontal mullions to reflect light deep into the office space. C, low E coating on surface 2 on the southeast side. D, low E coating on one of the double glazed window surfaces on the north side. E, window systems with a high U value. F, laminated glass at all skylight locations. So this is a little specific, sort of hoping that you understand about low E and how double pane windows work. So if you imagine a double pane window, so there's 2 sheets of glass, and then there's like a little element that holds them apart from each other so that there's a thing that stops a cold bridge from moving across. So we have surface 1, which is the outside, and then there's surface 2, which is the inside of the outside pane. Then there's surface 3, which is the et cetera, and then surface 4, which is the inside. So by looking at A, we're talking about would the low E coating go onto surface 1, which would be this outside, if you imagine this is the outside and this is the inside, this outside element. Well, low E coatings are like plastic sheeting, and you wouldn't want to put them on the outside because they get damaged if you had hail or a branch rubbing up against it or somebody scratching it or something. You'd actually see it and it would start to mess up and it would become a problem. So it's not going to be on surface 1 on the south side. Low E coating on surface 2 of double glazed windows, well, that means it's right there. That's on the inside face. That actually totally makes sense because you want the low E coating before the solar gain has gotten into this space. So being on surface 3, not so great. It's okay, it's better than surface 1, but it's not as good as surface 2. And again, being on surface 4 is not as good as either 3 or 2, and 2 is definitely the best one out of all of those. So this one is certainly a keeper. Reflective sills and horizontal mullions to reflect light deep into the office space. We already talked about how much they're interested in daylighting, so that sounds like a good answer for the fenestration system. Low E coating on the north side. People will often put low E coating on the north side just because they say, okay, we want low E coating on all the windows, but it's not actually doing anything for you on the north side. So that one's not needed. And then we have one answer left out of the final 2, window systems with a high U value and laminated glass at all skylight locations. This one is just sort of a kind of a trick question about high U value. You want a high R value, and then a U value is the inverse of that. And we usually, when we're talking about windows, use U value, not R value, although you can use either. So in this case, you wouldn't want a window system with a high U value, you'd want it with a low U value. You'd want it with a high R value. So E is not correct, and F, laminated glass at all skylight locations, that's actually a code thing, you always have to do that. So yes, you would absolutely in the fenestration systems want laminated glass in any skylight. And laminated glass is just, there's layers, sheets of glass, and in between each one is a sheet of, essentially a plastic clear sheet that has sticky stuff on both sides and it kind of glues everything together. The idea is that if, let's say, somebody threw a baseball up onto the roof and it broke the skylight, if that was just a sheet of glass and the skylight broke, then all of those giant shards of glass are going to come tumbling down through the space and it would be unbelievably dangerous. So in this case, you throw the baseball up, you break the glass, but then the plastic kind of holds it all together. So it's broken and you're gonna have to replace it, but it's not gonna come raining down, slicing people's arms off or anything like that, which would be very unpleasant for everybody. I think we can all agree.
Agreed.
All right. Number 9, standpipe access will be where? So this one is actually just understanding the point of a standpipe and understanding kind of what sort of place it is. We already looked at the aerial photo. It's clearly an urban setting with a big main street. So the standpipe is the device that is used in order to, imagine you're a firefighter. There's a alarm has gone off. You arrive at the building. And you figure out that the fire is on the 4th floor. Are you going to tie your hose into a fire hydrant and then run in and run up the stairs to the 4th floor with a full hose? It's like, probably not. That's not, it's dangerous. As water is going to get all over the place, it's going to be in the stair, it's going to be a real problem. So instead, what you're going to do is you're going to tie a hose from a fire hydrant to the standpipe, which is going to be facing the sidewalk, number C, and that will then charge water from the hydrant into the standpipe. The pipe is then a pipe that will go from that front-facing element where the firefighters can pull their truck up and find it immediately. Can't be hidden around anywhere. It's got to be someplace they can see it. So in an emergency, they can get to it fast. That's why it's going to be right there at the sidewalk. It's then going to go inside the building and probably go right up to where one of the stairwells is, one of the egress stairs, and then it's going to go vertically right through the building. And then the firefighters can run up the building, and then they can tie a second hose from, let's say it's the 4th floor, they go up, they tie into the standpipe at the 4th floor, and then they can fight the fire. And that standpipe is now filled with water that has come from that fire hydrant that they just connected it to. So it's a way of extending the firefighters' hoses. Now, you can also use standpipes for sprinkler systems. You can use them for a couple of different things, but the idea is that they're a way for the firefighters to connect to not have to have hoses running through the whole building. It is the hose. It's like a hard hose. And the reason that it's facing the sidewalk is they have to be able to find it. So we figured that out by looking at that aerial photo and understanding the urbanness of what's going on. Okay, number 10, given the environmental concerns on the site, you, the architect, should recommend that the owner do which of the following? So before we'd answer this, we would probably go through and read that phase 1 and really go through it. I will tell you that if we did that, we would find that sure enough, there is asbestos, lead, and an underground oil tank are all mentioned in that phase 1 as things to be worried about. So clearly that is a reasonable set of things to be thinking about. But let's look at what the question says. The question says, given the environmental concerns on the site, you, the architect, should recommend that the owner do which of the following? Well, if we actually answered C, we would be saying, we recommend that you remove the asbestos, lead, and the underground oil tank. That's not really something that the architect is commissioned or knowledgeable enough typically to be able to truly say. There are other things we might be doing. We might encapsulate lead paint or asbestos. We might cover an old oil tank in concrete or something and leave it right there. Probably the oil tank we'd probably remove, but maybe we would need to remove some of the soil around it. Hard to know without having more specific information. So C is one of those ones that sure seems like a good answer, especially if you read the phase 1, but it's not the right answer for an architect. An architect is not going to be telling the owner yes, you should remove the asbestos. The environmental engineer is the one who's going to be doing that, and the way they're going to be doing that is through the phase 1 and phase 2. So let's look at some of the other answers and see what we get. A, remove the first 3 feet of contaminated soil and follow the phase 1 recommendations. Again, there's really nothing that says that 3 feet of soil needs to be removed yet. We just don't have that information. It doesn't say that anywhere in the phase 1. So there's no reason why we would be going out of our way to make that up to talk to the owner. So it's not going to be A. So then the final one is D, encapsulate the site with concrete pad and prepare for testing. Well, again, maybe that's what we're going to do, but we just don't know. It's not our place to make that decision. So our place is to help the owner and to recommend to the owner that they get the next phase of the report. And the reason that they would need to get a next phase is because the phase 1 says you need to get a phase 2. Often, when you do a phase 1, they'll go through the history of the site, they'll go through the photographs, the aerial photographs, and they'll say, we don't really need to worry about it. It doesn't look like there's anything. I wouldn't worry about it unless some specific information comes. At which point, you can go ahead and recommend, phase 1 doesn't say that we need a phase 2. I recommend we move forward with our design. That's fine. But you would never be saying, I recommend that we paint over the lead paint and hire my Uncle Jimmy to take the asbestos out, and by the way, let's just fill that oil tank with concrete. Like, that's way too specific information. You don't have enough information to be able to answer that. So the best answer in this case, because the phase 1 said so, get a phase 2 environmental report, which is where they do all the testing and really get into it. And then there'll be a lot of recommendations, and you would help the owner sort of parse the recommendations that came from the phase 2. You might have a couple choices, and some might be more costly than another, and so you might be part of helping them to understand it, but you're not going to tell them what to do when it comes to environmental.
All right, we're down to 3.
All right, last here. What is the FAR and approximate allowable building area for this site and occupancy, and is this enough to meet the needs of the client? So we have a couple of different answers here. A is FAR at 2.2, B is FAR at 5, C is FAR at 3, and D is FAR at 3.5, so the floor area ratio at any of those numbers. And then there's different allowable building areas set there, and some yeses and some nos. So probably the first thing we're going to want to do is take a quick look at the zoning code and try to understand what we think the FAR is likely to be. So let's do that real quick. All right, so what does it say? We have floor area ratios for the B and C districts. Dash 1, 1.2, dash 1.5 is 1.5, dash 2, 2.2, dash 3. Our zoning is B3-3, so we are a dash 3. So there we are right there, 3. But wait. This is one of those things we were just talking about, how you have to read the next little section to make sure that there's nothing that then says, well, wait a minute, what about in this kind of situation? And right here in the very next section, they have FAR increases for transit-served locations. And so it has within 2,640 feet, if you're within a transit-served location, and you are a dash 3, there's the dash 3 part right there, you can raise it up to a 3.5. So let's see, do we think, we already know the answer to this, but do we think we are within essentially half a mile of the transit station? Well, yeah, we're right across we're half a block away from the transit station. So we are definitely a transit-served location. And so we are able, in that case, to bump up from a FAR of 3 to an FAR of 3.5. So now let's go back and look at our answers. If we have 20,000 square foot site and we have an FAR of 3, let's say, then 20,000 times 3 would be 60,000, and our building is 40,000. So yes, that one would meet. But we also have this potential for upping it to 3.5. So FAR of 3.5 times 20,000 square foot of the site area. That's the floor area ratio. We're allowed to build, the allowable building area is the FAR times the site area. And so 3.5 times 20,000 is going to be 70,000. That's definitely more than the 40,000 that we have in our expectation. And yes, it meets it. So the answer here is D.
All right, let's see how many we're left with here. All right, good. Cool. All right, some good stuff here. So we do have, there's a lot of questions. I can sort of simplify this down into really sort of 2 questions. We'll do questions first. If you guys are listening right now, do me a favor. We're looking for some new ideas for our next episodes on ARE Live. So if you would do us a favor, if you have an idea for our next episode, would you throw it into one of the questions so we can sort of, do what you guys want? In the meantime, 2 questions. This one's kind of specific, but 2 folks asked about shallow floor plates. One's, Erica said, what's a shallow floor plate? Leah asked, can you explain why shallow floor plates make for close access to windows? So there's some general questions about shallow floor plates.
So, okay, real quick, I'm going to do it on the wrong drawing here just so we can get to it. Imagine you're the architect for what was known as the Sears Tower, right?
I like that. Don't call it. It's a current name.
Yeah, the building formerly known as Sears Tower. And it's a huge, big floor plate. And that kind of made sense back in the day in the 60s and 70s when you had, 20,000 secretaries sitting in the middle of these giant floor plates typing everything up. And so there's just huge numbers of people all sitting very far from the windows. You know, that might be 60, 70, 80 feet, something like that, far away from the window. A shallow floor plate says, well, wait a minute, that's not healthy for people. And as it turns out, these days, these floor plates are really difficult to figure out how to rent them because it's just so big, nobody really wants to be in that middle. Obviously, you have the elevators and the bathrooms and all that stuff in the cores, but nobody really wants to be that far away from a window. In Germany, there's a bunch of rules. I don't know the rules specifically enough, so I don't take the numbers I say specifically, but essentially they have rules that any building that's an office building, anybody who's working there can't be farther than about 30 feet from a window. Now I could be wrong. I think it's 10 meters, which is about 30 feet. But you know, it might be a different number. But that whole thing came about that people wanted operable windows. They wanted to be near sunlight. So that is a shallow footprint. That is saying that everybody is near the window. You can't be in a plan somewhere and not be reasonably close to a window. So that's what that's talking about. These giant big square. This is one of the reasons that kind of if you're renovating a huge old loft building, it's really tricky because they weren't trying to get windows near every square foot. But if you're using it as an office or as a residential, like what do you do with those internal, because they're not shallow, they're very deep floor footprints.
Okay, and then the other question a lot of folks are asking in a lot of different ways is really they're looking for a strategy for how to think about taking these case studies. And by that I mean, how much time should you allot for it?
Yeah.
Do these count more than the regular questions?
Right.
All that sort of stuff.
So first of all, every question counts the same as any other question. So it's just that you happen to get a bunch of questions that are about one topic. But each question counts the same. So if you have 15 questions, it just counts the same as 15 regular questions. So the trick here is you're going to want to, when you first get into the case study, oh, and by the way, you can choose to jump ahead and do the case studies first if you want, and then go back and do all the single questions. And I think the decision to do that is really about you and how you take exams. My worry about people doing the case studies first is that you can kind of get lost in a lot of the information if you allow yourself to. So like if you're somebody who you think, oh, I'm gonna just get sucked up into it, I'm gonna start reading the whole building code.
Yeah.
Well, then if you did that first, suddenly you're 3/4 of the way through the entire exam and you haven't even answered any questions yet. That's a disaster.
Yeah.
But if you sort of feel comfortable with the ability to kind of move through the tabs and do the searching and kind of like how you're going to do it, well, then that might be a way to kind of make yourself feel better. And then you get all the case studies done because those are the trickier part. And then just go back up and finish off all the one-by-one questions. And so it really depends on whether that's a worry for you about whether you get lost in that information. Because I think for some people it's going to make more sense to say, all right, I got 20 minutes left, I got to answer these things, I got to move through this information really quickly, and that'll kind of keep you on your toes. So the first thing is, there'll be information. We had it as the scenario, we had it as a separate thing, but that would actually be part of that main screen as you first came on to the case study. You're going to want to read that very closely. It won't be very long, but you're going to want to read that very closely. There's going to be information in there. And then there's going to be probably one or two other pieces of information that you're also going to want to read. There'll be shorter pieces of information. They might be visual, like a wall section or something like that. Where you're going to want to go through it reasonably closely so that you kind of know what you're dealing with. And then there's going to be the other ones the sort of middle ground where you're not going to go through it all that closely, but you're going to want to see what's there. So you're going to scan through it. You're going to take a look, like the zoning code might be a good example. You're not going to read the zoning code, but it'd be interesting to know what pieces of the zoning code they gave you, so you can know whether that's a place you can look for information. So you're going to scan through that. Well, when you get to the IBC, like if they give you a code, you're not going to read the code. You just want to sort of see what sections they give you. So there's going to be a couple that you're probably going to read. Those are going to be the ones that are maybe a page or possibly 2 pages long. There's going to be a few that you're going to want to just sort of check the headings, so you kind of know basically what information is there. And then there's some other ones that you're just going to know, all right, I'll get to it when I find a question that I know pertains to it, and I'll just find the specific information. So the first thing you're going to do is kind of place yourself on that information to try to understand, first of all, understand the scenario, so I know what I'm looking for, I know what I'm looking at. Understand the key pieces that I want to read all the way through, so that in this case probably the program would have been a good one to read all the way through. It would have told us a lot about scale and size and kind of what they were interested in, and it would have made it easier to look at all of the other elements. But again, you're not going to read the code, you're not going to just start from the beginning and read through. You just want to have an idea of what's there. So that first thing you're doing is you're sort of dividing those tabs into those different categories. Which ones are the ones I'm going to read or really look at, like a photo, and which ones are the ones I'm just going to understand the big headings, and which ones I'm just only going to look at if a question seems to take me there.
Yeah, and guys, I think what I'd probably recommend is, remember, again, going back to what Mike's just said, the case study questions are not weighted more than the regular questions, but they probably take longer to do because there's a lot more going back and forth and so forth. So if I knew that the exam had 100 questions and I knew it was 4 hours, like I would kind of go in and I would probably try to knock out all of the not case study questions first, and I'd give myself kind of a metric. I'd say like, all right, I want to be at 1 hour, I want to be through 30 questions of the multiple choice, and then at the second hour I want to be through 70 questions, to give yourself some metrics so you can sort of make sure you're pacing yourself.
That's a great
And then
idea.
I'd probably give myself a little bit more time. So if, for example, you were giving yourself 2 minutes for every multiple choice question, maybe give yourself 3 or 4 minutes for each of the case study questions. So you have some sort of a gauge. They're probably going to take longer. And again, since they're not weighted anymore, you probably want to get through all of the faster ones first. Would be kind of
I would certainly do it that way. And the other thing to remember is they're not going to take longer because the question is going to take longer. They're only going to take longer because you have reference material and you have to get through the reference material. And on any question, whether it's a single one or part of the case study, don't get overly caught up if you got one that's a problem. As you go through, you'll find there'll be some that just like, wow, I have to go back through and really think this through, or I've got to do a really long calculation or something. Like, if it's looking like it's going to take 3 or 4 minutes to answer one particular question, just make a guess and move on.
Yep,
it's not worth spending that time. And then if you got an hour at the end or 40 minutes at the end, go back and maybe you spend a little time doing some of that extra level of calculation, or really think it through how the wording works or something like that. But nobody is expecting anybody to spend longer than 2 minutes. Is probably a pretty good, it's probably even shorter than that. It's probably more like 1.5 minutes, like 90 seconds or something, on any one of the regular multiple choice questions. And so if it's taking you a really long time, it probably means something's not quite right. Move on. You're better to relax and keep rolling than fret about it.
Awesome. All right, before we finish up here, public service announcement. ARE 4.0 is almost over. It expires on June 30th. If you didn't know that, good thing to know. I'd ask you probably on behalf of NCARB, and just for the sake of humanity, tell someone who you think might be taking ARE 4.0 or who have taken it in the past.
All those people who have one exam left, you better get on it because they're going to start running out of places.
You literally can't take it after June 30th. Yeah. So that's my public service announcement. I want to thank you, Mike, and thanks to everybody who submitted their questions today. Our next ARE live broadcast is going to be your very famous top 10 tips to pass ARE 5.0.
That's pretty fun, that one.
The link is in the chat box. Go to blackspectacles.com/podcast. You can register right now. There's a link sitting right there. And again, if you can't attend, it's fine. We'll send you a video after the session anyways.
And we'll be doing a similar thing at AIA convention. So anybody who's going to the convention, come check us out.
That's right. We'll be on the expo floor. So you can get your picture with Mike Newman.
Yeah, don't break your camera.
Let's see, what else do we want to talk about here? Again, firm memberships. If you want your boss to pay for your membership, go to blackspectacles.com/firms. Send us a little information and we can get in touch. Doesn't matter the size of your firm. Also, as I said at the top, we're excited to be the NCARB's first ever approved test prep provider. I know it's a little pitchy, but honestly, the practice exams we built them so that you could basically have as close of an experience to the real exam as possible. So I'd really highly recommend it. The two courses that they approved for us were PPD and PDD. The other ones are currently under review, so we'll let you know about those. Our individual discount, for those of you who are ready to start preparing for the ARE right now, you can use coupon code CASE5818YT to get a 15% discount for the entire duration of your ARE exam prep membership. Finally, tomorrow we'll send you an email follow-up about today's ARE live broadcast. Please let us know what you think. We'd love to hear any suggestions for how to make this better or what topics you'd like us to cover. I promise we read every word that you write and use them to tune our next episodes. So thanks for tuning in.